Good morning, everyone. I'm Shagufa. I'm presenting with my group mates Rosa, Chris, and Sinhoy. Today, I'm going to talk about hydrogen production from dry reforming. Our speech includes 6 parts. First, I will introduce today's environmental problem, global warming. Second, alternative energy. Third, hydrogen production from dry reforming. And then potential and limitations, feasibility in Australia, and at last, conclusion. Okay, let's start with global warming. In today's societies, one of the major environmental problems is global warming. The main cause of this is carbon dioxide emissions. Most of these emissions come from burning traditional fossil fuels like coal, oil, and natural gas. To reduce this problem, we need alternative and several types of alternative energy sources. Some common examples are solar power and wind energy. They are mature, but they depend on weather conditions, and the biggest challenge is their instability. Other energies like hydrogen, hydropower, and nuclear energy are potential, but still in the developing stage. We could find that all of them have one big advantage. They produce less greenhouse gas compared to fossil fuels, which helps to protect our environment and build a sustainable future. Among all of these clean energies, hydrogen is receiving particular attention in Australia because of its abundant renewable resources and strong government strategies and the ambition to become a long and leading global exporter of clean energy. So far, electrolysis still remains the dominant approach compared with others. However, dry reforming as an emerging technique may prove particularly suitable for Australia.
Hi, I'm Rosa. So let's talk about hydrogen production from dry reforming. Dry reforming is a very potential method used to produce hydrogen from natural gas. The formula is shown on the slide as you can see. Dry reforming involves the reaction of natural gas such as methane with carbon dioxide, and it produces syngas, which is a mixture of carbon monoxide and hydrogen. Of course, a catalyst and heat are needed in this production, and in this case, the catalyst is nickel. This initiative is still in an early stage where idea is being formed and critically analyzed for its feasibility in Australia. According to the research by Hunter, Huang, and Jiang in 2025, the Middle Arm region in the Northern Territory is an ideal location for dry reforming hydrogen production because there's abundance of methane from offshore gas fields, and the existing ports and transportation infrastructure is an advantage to this new production. It is also backed up by the government's initiative, such as the Northern Territory Government's Middle Arm Sustainable Development Precinct Initiative. The life cycle analysis of hydrogen production from dry reforming is still limited, as this is still a new technology. However, with the existing literature, we can draw conclusions that in the production process, carbon dioxide is actually reduced from the atmosphere rather than emitted. And the critical point is storage and transportation that needs to be considered, such as by hydrogen liquefaction or compression to reduce carbon emission with efficient transport.
Thank you, Rosa, for introducing hydrogen from dry reforming and the project in Australia. Now, let me show you the advantages and the limitations. The first one is no water needed. Dry reforming of methane does not use processed water, so it can suit Australia's dry regions. And it also used CO2 on site. At the gas processing hubs, we can feed the captured CO2 into the reactor. So there's less venting and less transport. The third one is small land footprint. We plug into existing liquefy natural gas area and reuse steam missing, reforming people and equipment. That cuts up front cost and saves time. The first one is flexible products. DRM make syngas, a mix of H2 and CO gas. We can turn it into methanol or FT fuels instead of burning the CO. What about the limitations? The first one is not zero carbon by itself. If we burn the CO or run WGS without CCS, the CO2 go back up the stacks. It also needs very high heat. It needs about 600 to 800 degrees without low carbon heat. Costs and emissions go up. And the catalyst life, nickel catalyst can coke and sinter, so they don't last long enough yet. And how can we get pure hydrogen? If we want to get pure hydrogen, it needs so much extra steps. That adds cost and a lot of time. So what is the meaning for Australia? DRM feeds gas and CO2 hubs where water is limited and there's real syngas demand. If the goal is large-scale clean hydrogen, pair DRM without low carbon heat and CCS. Otherwise, SMR and CCS or electrolysis may be the better choice today. Thank you, everyone. Now, my group mate Xinghui Shi will introduce feasibility in Australia.
Hello guys, I'm Xin Hui. Now I'd like to talk about the feasibility of this technology in Australia. So before this, I think we need to learn about the environmental characters in this land. Australia is a freshwater scarcity country, and in this land, the nickel element is abundant, which means if we want to develop or fund the new hydrogen production technologies, we need to consider these two constraints. So in this page, I list the former hydrogen production technologies include the electronics, steam reforming to compare with the dry reforming. We could fund only dry reforming, no need to use the fresh water. And the material of catalyst also use the abundant element nickel in Australia. But one of the critical problem is the hydrogen production is relatively low, only 24 to 30%. We found in other papers, they indicate so far this technology is mainly used in downstream applications, such as methanol and FT synthesis. So if we want to improve the hydrogen production, if we want to get more high purity hydrogen, maybe we need to update the performance of the catalyst. And in terms of the social feasibility, this technology could satisfy the political target by 2015, and it also meets the market demand because they could regard it as the commodity to export. In terms of the economy, the author indicate the total energy expenditure of steam reforming and dry reforming is similar and cheaper than electronics, and no need to construct the new plants, because the dry reforming could also happen in the steam reforming plants, which means it saves the construction cost. But unfortunately, according to our investigation in Australia, there are only 16 steam reforming plants used to produce the hydrogen. So if we want to make the dry reforming dry reforming become the big scale, maybe we need to wait several years. And in the future, the scientists need to think how to develop more efficiency and carbon-resistant catalyst, how to integrate with the carbon dioxide capture and purification technologies. And the last one is my point of view, maybe not right. I think this technology is still rely on the traditional energy, because we have mentioned the methods comes from the natural gas, but natural gas now belongs to the alternative energy, right? So I think if we want to choose, we want to use the alternative energy, not only because they are clean, but also they could provide the sustainable energy. So maybe in the future we need to think how to collect them from the sustainable way. For example, how to collect them from the paddy field, how to collect them from the wetlands, because these two places are the main source of the method. And figure 3 shows the latest latest research in 2025, they found under the ion member in paddy field, there are lots of methods. There are high concentration of methods, but they don't know how to collect them. Okay, at the end, in the end, I will give you a quick conclusion. The dry reforming is not very mature so far because the low hydrogen production. And if we want to, but it can be regarded as the promising way because it could mitigate the two types of the greenhouse gas. And so far, this technology can be utilized in downstream chemical process. If we want to use it to produce the hydrogen, to produce more hydrogen, maybe we need to enhance the thorough or catalyze the update. Thank you for listening. This is our presentation, and these are our references.